One of the places where horizontal translations become a little bit more complicated is when we combine a horizontal translation with a horizontal dilation. In other words, if we have a trig function where we have both a change in period and a change in the phase, we end up with a combination. These two things will sort of interact with one another, and part of the reason is the way that we write these. Some books choose to write these transformations slightly differently to untangle them, but our book uses a format that combines them together in some regard. So here we have two different pieces. We have k and c. K, recall, affects the period. The period of our trig function here is always going to be 2 pi divided by k. But our phase shift now will end up having this c value, which has been important all along, but also this change in period. Both of these will become important. And our phase shift we will typically write as minus c divided by k. This is the value of the phase shift. You'll notice that k value, which helps us to determine the period, also plays a role in determining a phase shift. So let's take a look at an example of this to see why this is the case. This is not an obvious thing for many people, and this is one of the more complicated parts of graphing these trig expressions. So let's take a look here. Let's look at an example of f of x is equal to the sine of 2x minus pi. And this is a good example for you to get your graphing calculator out at and actually look at what the result is. And you should be doing that with all of the problems that we're working on. Whenever you can check your answer, please check your answer. Don't rely on your calculator to give you the graph, but simply use it as an aid in checking your results. I've left off vertical shifts and amplitude changes because those are relatively straightforward, and we don't see any complication or connection between those. But let's take a look here. The basic parent graph for sine, again, I know you're going to get tired of seeing this, but I never get tired of drawing it. This is the basic parent graph for sine. This will be our y equals the sine of x. And let's start to think now about the changes that we are implementing. We have a period of our function now that has changed. Our period is 2 pi over k. In this particular case, that leads us to a period of pi. But our phase shift also changes. Our phase shift, recall, is going to be minus c over k. C in this case is minus pi, so we have minus and minus pi. And k is 2, so we have minus negative pi over a k value of 2. And that's going to lead us to a phase shift of pi over 2. Now the minus sign in this formula for phase shift was chosen to correct for the fact that it's always in the opposite direction. So the fact that we end up with a phase shift here of pi over 2 that is positive tells me that my graph is going to be shifted to the right. You can also get that from the fact that this was a negative value here as well. Once again, I'm not going to do all of these transformations all at once because that gets to be overwhelming. Let's start by looking at the change in period. My graph now will have a period of pi. And so this is what the graph of the sine of 2x should look like. And I believe we've made this graph before. You can check to see that that is the case. We'll clean that up just a little bit there maybe. So here we have y equals the sine of 2x. Our next step is going to be to implement the phase shift, and the phase shift is going to shift every point on this graph pi over 2 units to the right. So this point, for example, will now get shifted over to here. That's a distance of pi over 2. That's half of the distance to pi. And that means that basically every part of this graph will be flipped, and so we can go through and come up with the change in the graph relatively easy. There's a nice combination, a good example to start with here, of a combination of a phase shift and a period change. This will be the graph that we expect to see as a result of both the phase shift and the period. So here, this is our graph of y equals the sine of 2x minus pi. It's important to recall and make use of these formulas that we've written up on the board here previously. So this is the most important idea that we've seen today. Vertical shifts are fairly straightforward. What we'll be looking at on Tuesday will be combining all of these operations together. What happens when we have functions that contain horizontal and vertical shifts, as well as amplitude and period changes. It gets rather complicated. We will be looking at both writing and graphing these kinds of functions on Tuesday. So this will be the work that we will do for lesson 6-5, and we'll look forward to seeing you in class, and we can work together on this. Thank you.